Hello guys, this is Sushant. Welcome to my YouTube channel again. And today we're going to be reviewing all solutions for the Kangaroo Math Grades 1 and 2 level year 2020 paper. Thank you. Let's get in. 1. The kangaroo goes up 3 steps each time. The rabbit goes down 2 steps. On which step do they meet? Okay, so it is given that the kangaroo goes up 3 steps and the rabbit goes down 2 steps. So with that, we can start. Well, so this is the first move. 3 steps, and that's 2 steps. Another 3 steps means from 3 it would go to 4, 5, and 6. So it jumps all the way from here to there. That's another 3 steps. Now the rabbit's at 8. So going down 2 steps means it would go to 7 and 6. So the kangaroo's on 6 and the rabbit's on 6. And they asked which step do they meet. And since they meet at 6, the answer is D, 6. 2. Mordka took a selfie in front of this castle. On which of the pictures could be Mordka's photo? Okay, we know the smiley faces is Mordka's face, and now we have to see which is correct or which matches. So let's compare this original image on the top to A. So the first one should be a point, something like that. And here we cannot see it anyway. So let's move on to the second shape. This is like a square. And here it's also like that, which means this is correct so far, but not fully. Let's check the third one. The third one is supposed to be pointed, but here it's not pointed. It's in a square shape, which means A is wrong. B. So looking at B, the first one is pointed, and the second one's also pointed. The second one is box shaped. Here it's box shaped, but the third one is supposed to be a taller point. But looking at it, we know this is not a point. This is in a box shape, which means B is wrong. C. See, first there's a point, there is a point, there is a box shape, there is another box shape. But this higher point should be visible from Mordka's height, and it is not visible at all. That means C is wrong. Now D. Looking at D, we have this small point. This is a point. This is a box, another box, a tall point, two box shapes, and a small point. But the thing, how D is wrong is because here this is shorter, but here they seem to be the equal height, which means D is wrong. And E is our only leftover option, and still if we check, we have a short point, a box, a taller point, and we have this box, and we also have this point ending it. So even if we don't see this part of it, we still know that this has gotten the closest. So E is the answer. 3. Nellie arranged the 4 pieces to make a picture of a kangaroo. How are the pieces arranged? So they've given us numbers on the top corners of each piece, and they've given us options with the numbers. Now we have to see which is correct. If we look at it that way, 3 clearly seems to be the head, and 4 seems to connect as the ear, because number 2 is a tail, and number 1 is the body, which means they cannot be it. And if we look at 4 and if we try to put it, we can still see that they match, which means this is 4, and on this side is 3, the head. So 4 is the ear, 3 is the head. Now we have to figure out where 1 and 2 can really go. If we look at it that way, number 1 seems to be the body. If it connects from this space, then if number 1 goes down, this seems to be the body. So if 3 is the head, it goes under the head, which means number 1 is here, which number 2 is automatically going to go there. And if we look at it, it's option A. 4. A magician is pulling toys out of his top hat. He always pulls out the toys in the same order as shown in the picture. The pattern in the picture repeats every 5 toys. Which 2 toys does he pull out next? Okay, so it says the pattern in the picture repeats every 5 toys. So if we look at it that way, that means the first 5 are these ones that I've marked. These are the first 5 toys. And if we look at it, they repeat. First the rat comes again, the snail, 2 birds, and the frog. That's totally 5. And it repeats in the same pattern. Then the rat comes again. So after the rat, according to this pattern, the snail and the bird come. Since it's asking which 2 toys does he pull out next. And according to the order, these 2 come next. And if we look at it, that is option E. 5. Jose has 2 cards of the same size. Card A has 4 holes cut in it. Jose places card A directly on top of card B. What does Jose see? Okay, so if we put it that way, so there is going to be some holes. So the holes will be one here, and another hole will be somewhere here, and another hole will be here, and then the 4th hole would be there. But if we look at it that way, this one covers black, okay? And then this one also has a black star. This one also has a black, and on the bottom here, there is no star, which means it's going to stay white or gray. If we look at it that way, A matches it. 3 are dark, and this one is light. So the answer is A. 6. Mary made a shape using some white cubes and 14 gray cubes. How many of these gray cubes cannot be seen in the picture? Okay, we already have 1 gray cube, 2, 3, 4, 5, 6, 7. And we know that a cube is 3-dimensional, which means this and this side are the same thing. It's the same cube. So that means this is a different cube though. So this could be counted as 8. So we have 1, 2, 3, 4, 5, 6, 7, 8. So that's 8. But in the total, he used 14 gray cubes, which means 14 minus 8 gives us a leftover of 6, which means 6 is the answer. 7. Anna draws a picture of some shapes. Her picture contains 3 black triangles and fewer than 4 squares, which could be Anna's picture. So her picture contains 3 black triangles. So if we see any of these dotted triangles, that's not it. It has to be black. And fewer than 4 squares. So if we look at it that way, there is 1 triangle and 2 triangle. There is a 3rd triangle, but as it said, it has to be black, and it's not black, which means we don't need to check for squares. It's wrong. And B. In B, if we look, there are 1, 2, 3 triangles. You could count 1, 2, and 3. And it says fewer than 4 squares. If we look here, we have this is 1. It's not a diamond. It's actually a square that's tilted. So this, if this is 1 square, 2, 3, and 4, it says fewer, not equal to 4. So that means B is wrong. C. See, there's 1 triangle, 2 triangle. There is a 3rd triangle, but the 3rd triangle is dotted, not black. It's wrong. D. D, there's only 1 triangle, and the 2nd triangle is dotted, and there's not even 3 triangles, so D is wrong. E. There is 1, 2, 3 triangles, and squares is less than 4. And as I said, these types are tilted squares. If you think that's a diamond, it's not. It's tilted square. So if we look at it that way, we have 1 square, 2 square, and 3 squares. And 3 is smaller than 4. So answer is E. 8. The braid in the figure is composed of 3 threads. 1 thread is green, 1 is blue, and 1 is red. What colors are the 3 threads? Okay, so they've given us these numbers 1, 2, and 3, and they want us to follow these lines of the braid and see which is which. So let's start off with green, the top one. So green starts here. It's going through somewhere like here and continuing all the way down there, and it's going under this like that, and it's kind of going down under like that and goes there. So green is 1. Now blue. Blue is here, and the blue is kind of going under the green, and autumn is going there, and it goes there, and it continues to go to number 2. And we have 3, which is, well, we have 3, which is going to have to be red. But just to check, let's see. This goes on like that, and this goes on like that, and that goes 2, 3. So if we look at it, 1 is blue, which is wrong first because 1 is green. So A is actually wrong. So let's look at B. 1 is green, yes. 2 is red and 3 is blue. That's wrong because 2 is blue and 3 is red, which means this is wrong. And let's look at C. 1 is red, which is wrong because 1 is green. So C is wrong. D. 1 is green, correct. 2 is blue, correct. 3 is red, correct. But let's check E too. 1 is blue, which is wrong because 1 is green. So E is wrong, and that leaves us with the option D, which is correct. So the answer is D. 9. Which piece completes the picture? Okay, they gave us a total of 9 tiles and wanted us to find the middle tile, which we did. Well, I have already I already drew what should be here. Now all we need to do is we need to compare it to the options. Looking at it to the options, there should be 1 edge with the half of a clover, 2 edges with the half of a spade, and an edge with the half of a heart. We have to be careful because they might trick us by rotating the tiles. So here there is 2 halves with a heart, 2 edges with the half of a heart, and there is no clover edge, which means this is wrong. So let's go to B. So in B, well, we have to be careful because they might also rotate it. Remember that. So there should be 1 edge with a clover, with the half of a clover, And there should be 2 with the half of a spade, which there is. And there is also one edge that should be with the half of a heart. And there is 2 clovers and no heart, which means this is wrong. C. In C, there should be 1 edge with the half of a clover, and there should be 2 edges with the half of a spade and 1 edge with the half of a heart, which could make it correct, but we need to check the others just to be sure. D. They have 2 edges with the half of diamonds, which there shouldn't be because in this tile there shouldn't be any diamond. So D is wrong. E. There is one. There is 2 spades and 1 heart, but there should be the half of a clover on one edge, but there is the half of a diamond on the edge. So E is wrong. And so that makes C the right answer. 10. A village of 12 houses has 4 straight roads and 4 circular roads. The map shows 11 of the houses. On each straight road there are 3 houses. On each circular road there are also 3 houses. Where on the map should the 12th house be put? Okay, so if we look at the circular roads, we see that the inner circle, the most little circle, has 3 houses. The second layer has 3 houses. The third layer does, but the layer with E and C put on it only has 2 houses, which means that this outer layer of circular road has to have an extra house, which either could be E or C. But looking at the straight roads, all of them have houses, but all of them have 3 houses because the one with B on it has 3 houses. The one with E on it has 3 houses. The one with D on it has 3 houses. But the one with A and C on it do not have 3 houses. So if we look at it, if we put a house at A, so if we put a house somewhere like right there, the H is for house, then this straight road with A and C would have 3 houses. But that means this outer ring does not have 3 houses. It would only have 2. So if we put a house at C, that means this straight road has 3 houses, and this outer ring circle here also has 3 houses, which means this which means it has to be put at C. 11. 5 shapes are made by gluing cubes together face to face. Which shape uses the most cubes? So we have 1, 2, 3, 4, and 5. So this one, the first one, A, has 5 cubes. B has 1, 2, 3, 4, 5, but it's not exactly 5 because if there is this 5th cube over there, of course there has to be a cube under it, which would be the 6th cube, which means it's 6 cubes, not 5. C. There is 1 cube, 2 cubes, 3 cubes, 4 cubes, and here we see a tippy top of the corner, but that is still a cube, which means that's the 5th cube. This is the 6th cube, and if the 6th cube is there, that means there has to be another cube under it, which means there's a 7th cube too. So it's 7, not 6. Here we see a tippy top corner, but it's still a cube, so that's 1, 2, 3, 4, 5, and 6. But if the 3rd cube is up there, there has to be a cube under it, which means there's not just 6, there is a 7th cube. So here there is 1, 2, 3, 4, 5, 6 and 7. But if 6 and 7 are there has to be a cube under them to balance it, which means it's not just 7, it's 8 because of the extra cube. So in all of them, E has the most cubes, which means E is our answer. 12. A number is written on each petal of 2 flowers. One petal is hidden. The sums of the numbers on the two flowers are equal. What number is written on the hidden petal? Okay, so both of the flowers have a number on each petal, and the sum of all the numbers on each petal is equal on both flowers. Since on one of the flowers we see all 5 numbers, so let's add it up. We have 5 plus 7, which would be 12. So 5 plus 7. Well, we have a plus 3 plus 1 plus 9, which would give a total of 5 plus 7 is 12. So 12 plus 3 is 15. 15 plus 1, 16. 16 plus 9, 25. So that means one flower has a sum of 25. But that also means this flower also has a sum of 25. We already have 6 plus 4 plus 2 plus 8, which would give us 6 plus 4, 10. 10 plus 2 is 12. 12 plus 8 is 20. But we need to have a sum of 25, which means 20 minus 25 would give us a leftover of 5, which means the hidden plant shows 5. 13. In which of the following pictures is more of the shape shaded than any of the others? So, okay, so they've given us 5 squares with 9 tiles, and some of the tiles have half square shaded, some have the whole square shaded. So now what we have to do is we have to see which has more shaded. So this one has 1, 1, 2, 3, 4, and 5. But that's not just it, because we have 4 halves. And we know that 2 halves together is 1. Half plus half is 1. Which means since there are 4 halves, these 2 halves can be 1, and these 2 halves can be 1. So 5 plus these extra 2 ones would give this a total of 7. And B. So in B there is 1, 2, 3, 4, 5, 6, but that's not just it, because we have 3 halves. So if 2 halves can be 1, this one and this one could be together. This half with this half together could give a 1. And this half doesn't have another half, which means this has to stay as half. So 6 plus this extra 2 halves being 1 whole tile means 7. But since there's a half, it's a 7 and a half. And C. C has 1, 2, 3, 4, 5, 6. And then since there are 2 halves, they can work together to make 1 whole tile, which means 6 plus 1, 7. Here is 1, 2, 3, 4, 5, and 6. But those are 6 whole tiles. But we also have 2 halves, and these 2 can work together to make 1. So 6 plus 1 is a 7. And this one has all wholes, so it's probably easy to count. 1, 2, 2, 3, 4, 5, 6, 7. This has 7. But all of them have 7, but only B has 7.5, which is still more than the others. So B is our answer. 14. Mary wants to write numbers 1 2, 3, 4, 5, and 6 inside the 6 squares of the figure. She wants a different number in each square. She wants both the sum of the numbers in the blue squares and the sum of the numbers in the yellow squares to be 10. What number must she write in the square with the question mark? Okay, so let's start off with 1 being over here, like that. That means the blue squares could probably have 5, 2, and 3. 5 plus 2 would be 7, and 7 plus 3 would be 10. But then now we have used 1, 2, 3, 4. No, we have not used 4, so let's keep that. But we have used 5. So all we have is 6 and 4. 6 plus 4 is 10 too. Yay! So today we have got it on the first try, and 1 is in the blank. 15. This card lies on the table. It is flipped over its top edge and then flipped over its left edge as shown in the picture. What does the card look like after the 2 flips? Okay, so here I already have drawn my images just because it might be hard to draw during the video, so I already have my images drawn. So now I'm just going to explain it. So if they made one like all the way up, that means everything must be upside down. They totally flipped it over. That means the triangle would be upside down. And since the square has 4 equal sides and it would not be rotated that way, which means the square would stay the same. And the circle would not be changed as well. Now they flipped it to the left, which means everything on the right would go to the left and everything on the left would go to the right. And if you want, you may also use a piece of paper. I'm not sure if that would be allowed in the real test, but for now, for your learning experience, you may use a real piece of paper for this to guide you. So when you do flip it, what would happen is the triangle on the right would go to the left. The square in the middle would stay in the middle, of course, and the circle, what is in the left, would become to the right. And if we look at that, only B matches that. So the answer is B. 16. Grandmother has just baked 12 cookies. She wants to give all of the cookies to her 5 grandchildren, but also wants to give each of the grandchildren the same number of cookies. How many more cookies should she bake? Okay. So here we could do it depending on how many she wants each grandchildren to have. Like if she wants each of them to have 4, she needs to bake this many. If she wants each of them to have 10, she has to bake this many. But we have such things as options. So if we go by options, we could see that only one of the numbers would equally be split into 5. So that's what we're looking for. So let's go on our options. A, 0. So if she bakes 0 more cookies, which is basically no more cookies, that means she would still have 12. If you split it 12 into 5, you would not get equal or whole cookies, which means 12, which means A is wrong. B, 1. If she bakes 1 more cookie, she would have 13 cookies. And if you split 13 by 5, you cannot get equally whole cookies. C. If she bakes 2 more cookies, that means she would have 14 cookies. And if it's 14 cookies, if you split it into 5, you cannot get a whole answer. You cannot get a whole cookie. So it's not correct. D, 3. So 12 plus 3 would give you 15. And if 15 is split by 5 groups, that means it could equally be split into cookies. And not just cookies, but like whole cookies. But just to check, let's look at E. E means 4. So 12 plus 4 would be 16. And of course, you cannot divide 16 by 5 equally, or it would not be a whole thing, or whole number, or cookie. Which means, so far as what we've got, D3 is our answer. 17. Tom has 9 cards as shown. He puts the cards on the board so that each horizontal line and each vertical line contains 3 cards with 3 different shapes and 3 different number of shapes. He has already put 3 cards as shown. Which card does he put on the gray square? Okay, so what they've given us is these 9 tiles. So these tiles each have like either circles, triangles, or squares on them. And they either have 3 circles, 2 circles, 1 circle, and either like 3 triangle, 2 triangle, 1 triangle, or as you know it, 3 square, 2 square, or 1 square. So if we look at it, they wanted us to fill it in with different numbers of shapes, with different shapes. Like if there's already a circular one put, and there's also a triangle for 2. So if we have to put one of those that has to have 3 shapes, it's either this shape or this shape or this shape. But they said they want 3 different shapes. If they want 3 different shapes, they've already used a dot and a triangle. So what's left is a square, which means that for squares, only this one is available. So if we put that, that means we have to put 3 squares, which I am probably not going to take time drawing. So they can be random like that for now. But now, moving on, so we know this is 3 squares, so we could also mark off this tile. And these tiles they've already used can also be marked off of the list. So now moving on, if we have 3 squares and two dots, that means for 3 different shapes, I'm going to keep it unaligned. That means if we use the circles and the squares, that means all we have left over is the triangles. So now we have 3 triangles or 1 triangles, but 3 squares is already used, so we don't need 3 triangles. We need only 1 triangle. So if we put it, we could put 1 triangle right there. So after that, now looking at this second column here, we have a 2 circular 2s. Like so so one of these boxes has to have 1 shape and one of these boxes has to have 3 shapes. But since there's already 1 box with 1 shape over here, this row here cannot have another box with 1 shape. So that means that only this box has to have a shape that's only one time there. So if we look at it that way, so that means this could either, well, we don't need to look at it because we've already used 1 triangle. It's already used 1 circle here. So all that's left over for 1 shape is this square. So we have to plug in this square with all we've got. So, and they have asked us what's in the gray square, and a square is in the gray square. So it is D. Two identical trains, each with 31 cars, are traveling in opposite directions. When car number 19 of one train is opposite to car number 19 of the other, which car is opposite to car number 12? So basically these both trains are going in opposite. Let's underline opposite. So both of these trains are going in opposite directions. If they're going in opposite directions, that means one's going this way and another's going this way. So that basically means what they're asking is if car number 19 from this train and car number 19 from this train both are meeting at one point at the same moment, if car number 12 from this train is somewhere there, it's asking what car would it be facing with the number, of course. So this one's like 31, this one's like 31, 30, 29, 28, 27, 26, 25, 24, and we're gonna go past that, 23, 22, 21, 20, and 19. So we've gone to 19. Now, this train is going more like this way. Now, the other train, of course, means it's going this way since they're going opposite directions. So, if there's 19 here, they're at the same place, that means this 20 is going to be facing 18 as well, 17, 16, 15, 14, 13, and 12. 12 at the moment is actually facing 26, which means our answer is 26. 19. Mark the bee can walk only on gray cells. In how many ways could you color exactly two white cells gray so that Mark can walk from A to B? Okay, so Mark can walk on all gray squares. That means this one, this one, this one, this one, all of them. Not just AB, but all of the gray squares, not the white. That means they're asking us if you can make two white squares gray squares, if you can transform them, and how many ways can Mark the B go to point B? No, Mark the B go from point A to point B. So that way, so first, for example, if well, let's use a ruler just for sake, something like in this angle. So then, we're going to make these two, the ones I have a line on, gray. If this one becomes gray and this one becomes gray, that means Mark the Bee can walk all the way from here past this bridge and go down and reach point B, which means that is an option. For example, if we draw a line somewhere here, that means Mark the Bee can go from A down and then go all the way up and go down to meet point B. That's possible. If we make these two squares, this one and this one, or hexagons, gray, that means this one and this one, well, it could go all the way down here, go up like that, which is also possible. So, that's not just it anyways, because, well, that's 3 so far, but that's not just all that's possible. What else is really possible is you could do this too, and so that Mark the Bee can go all the way down this way, and now climb up this way, reach this hexagon, and go down to point B. That's possible. If we make these ones gray, that's still possible because Mark the Bee can go all the way down here, reach here, go all the way down. You could go to here or here from both sides and go down to point B. That is possible. But past that, nothing else is really possible. You could check in all directions. This, and this are ones we've used. And there really aren't other ones that are possible here. So we know 5 is the answer. 20. An arrow pointing from one person to another means the first person is taller than the second. For example, person B is taller than person A. Who is the shortest? Okay, so if we want to see who is the shortest, first we need to look at the example. So these arrows, B and A, for example, it's saying person A is shorter than person B, which tells us that the one being pointed is smaller. So if we take E and F, for example, that means E is smaller than F because E is being pointed. That way, if we look at person B is, it says two arrows are coming out because that basically means that person F and person A are both smaller than person B. So far, person F and person A might be the shortest, but still not for sure. Now, person A also has an arrow going all the way to person D. And now person F is bigger than person E, and person E is also bigger than person D. So we might think it's obvious that person D is it. But we also have another arrow going from person D all the way to person C. And there's no one smaller than person C because they don't have any arrows going out anyway. That means person C is the smallest, so that's option C. 21. There are some apples and 8 pears in a basket, each of them green or yellow. There are 3 more apples than the total number of green fruit. There are 6 yellow pears. How many yellow apples are there in the basket? Okay, so let's kind of change the story a little bit, or just kind of add more. So she puts all of the fruits in one basket, but when she gets home, she's going to split them into 2 baskets, such as this. Now, let's keep it something like green over yellow. Again, green over yellow. They've given us the total number of pears is 8 pears. 8 pears. But the thing is that there are 6 yellow pears. So basically the thing is there are 6 yellow pears. Now, how many green pears are there? If there's a total of 8, 6 plus 2 is 8, which means there are 2 green pears. And now, 6 no, that's for the yellow pears. Now, it's said that there are 3 more apples than the total number of green fruit. So 2 plus 3 equals 5. The reason we're not subtracting anything there is because even if we add all of those green apples and then subtract it, we're still going to get the same difference, which is going to be 2. So we're just going to add 3 directly to 2, and that would give us 5, which means our answer is 5, and it's option B. Rule 22. Rule each of the numbers 1, 2, 3, 4, and 5 in one of the circles so that the sum of the numbers in the row is equal to the sum of the numbers in the column. What number could be written in the circle with the question mark? So, they're basically telling us these 3 numbers and these 3 numbers all. So these 3 numbers adding up would be a sum, and these 3 numbers adding up would be a sum. Well, a different sum, of course. So what they're telling us is the sums are going to be equal. So first we could put in 1. So that means we could cross off 1 from here. Now we have 2, 3, 4, 5. Instead of putting them in here and swapping them all the time, a simple way is that let's take 2 and add it with something like 5. That would get us 2 plus 5 equals 7. And now we have 3 and 4. If we take 3 and 4, 3 plus 4 equals 7 too. So 3 and 4 could be put here, something like this. Or they could be put in these two circles, but that doesn't matter. Either way, if 1 is in the middle, it is possible to be solved, which means 1 can be correct. That's not the answer because they've also given us or options such as 3, 2, or 4, 1 or 3, and 1, 3, or 5, something like that. So they have given us or options too. So let's try all of them and see which ones work and which ones don't. Putting in 2 like that. And that means we have, well, so we cannot do 1 plus 3, which would be 4, and then 4 plus 5 is 9. Those are not equal. 1 plus 4 is 5, and then 5 plus 3 is 8. Nope. 1 plus 5, 6. 4 plus 3, 7. Those two are also not equal. Even though they're just off by one number, they're not equal, which means 2 is not possible. So we are not going to write 2 here. Now, okay, so 3. We're going to put in 3 like right there. Okay. Now, we could do 1, right? We could do 1 plus 4, and then that would be 5. 2 plus 5 is 7. Nope. Let's try this. 1 plus 5 is 6. 4 plus 2 is also 6. And that could be written here too. Meaning like something like 2 and 4, 1 and 5. And that's also equal, which means 3 could be there too. Now going to 4. That means we have 1, 2, 3, and 5. So if we do 1 plus 2, that's 3, and 3 and 5 is 8, which is totally not equal. So 1 plus 3 is 4, and 2 plus 5 is 7. Nope. 1 plus 5 is 6, 2 plus 3 is 5, which means 4 being there makes it unbalanced. So 4 is not an option. Now 5, our last option, just like that. Okay. Now that means we could put in 1 plus 2. That'd be 3. And 3 plus 4 is going to be 7, which is nope, not equal. 1 plus 3 is 4. 4 plus 2 is 6. No. 1 plus 4 is 5. And 2 plus 3 is 5, which means that makes it equal. Like 2 plus 3 could be written here. 1 and 4 could be written here. And that makes it correct. So our answers are 1, 3, and 5. Which means 1, 3, or 5 is option E. So for 8, our answer is E. 23. 6 different numbers chosen from 1 to 9 are written on the faces of a cube. One number on each face, the sums of numbers on each pair of opposite faces are equal. Okay, which number could be put on the face opposite of 5? Okay, so in this cube, they're asking us what number could be put on the opposite face of 5 so that the sum of the numbers on opposite sides are equal for all pairs. And it said that not from 1 to 6, but pairs from 1 to 9 are written. And that doesn't mean a cube has 9 sides. That's impossible. Only 6 numbers out of 1 to 9, 9 numbers are chosen to be in this cube. We have to remember that. And of course, when we look at the options, one thing that must be clear is that if there's one number on a cube, there cannot be another side with the same number. That is a real rule in a cube. That means if there's 5 over here, 5 cannot be on the other side, on the opposite. So this B option is totally wrong. With that, we only have 4 options to look at. So let's see. So if 3 is on the opposite, that means 5 plus 3 equals 8. That means for 8, there has to be a 0 on the other side, so 8 plus 0 is 8. And it says 1 to 9, not 0 to 9. So that's not possible. Either way, 4 plus 4 is 8. And as I said, a cube cannot have two sides with the same numbers, which means that A is wrong. Now, C, 6. 5 plus 6 equals 11. Okay, now 4 plus 7 is 11. But the thing is that also 7 is somewhere between 1 and 9. So 7 can count. 8. 8 plus 3 equals 11 too. And again, 3 is between 1 and 9. So all of that works. So 6 can work. But just to check, let's go on. But I'm going to mark that with a check mark. Now, let's keeping going. So 7. So if 5 plus 7 is calculated, that would be 12. Now, then 8 plus what is 12? 4. But since 4 is already here, we cannot write 4 again on that side, which means 7 is wrong. 9. 5 plus 9 equals 14. Now, that means 8 plus what is 14? 8 plus 6 equals 14. 4 plus 10 equals 14. And from 1 to 9, 10 is not between. 10 is after 9, which means even if you include 1 and 9, which you are supposed to do, 10 is totally not in the list, which means if it is 9 that's opposite of 5, it won't work. Which means as we got 6 is our answer. 24. Olivia and John and Olivia exchanged sweets. First, John gave Olivia as many sweets as Olivia had. Then Olivia gave John as many sweets as John had after the first exchange. So we might think it's both 4, so I'm underlining it as after, so we know it. Now, the first exchange. After these two exchanges happened, each had 4 sweets. How many sweets did John have at the beginning? Now they've given us a really, really important clue. If each of them had 4 sweets, oops. But the thing is that we really need to underline this whole sentence. After 2 exchanges, each had 4 sweets, which means that 4 plus 4 is 8. So totally they both had 8 sweets. Now, how many sweets did John have at the beginning? Okay. Let's start with 6. Okay, so let's keep this as John and this as Olivia. J for John, O for Olivia. Okay, starting. If John had 6, Olivia had to have 2 because 6 plus 2 would be 8. That way, if John gave Olivia as many as she had, that means John would give her 2 because Olivia has 2, which means John would have 4 and Olivia would have 4. And Olivia would give John as many he had after the first exchange. The first exchange happened and then they have 4. So since John has 4, Olivia would give John another 4, which means John would have 8 and Olivia would have 4, which is totally different because they both have to have 4, which means A is wrong. B. If John had 5, which means that would make B for something like this. So like John has 5, Olivia has 3, totally that's 8. So now John gave Olivia as many sweets as she had. So if John gave Olivia as many sweets, Olivia has 3, which means John would give Olivia 3, which means we have to subtract 3 from John's list, which means that would give you 2. And Olivia had got 3 more, so that means she has 6. Now, it says Olivia gives John as many as she had after the first exchange. After this first exchange happened, as John gave Olivia 3 sweets, that means that John had 2 sweets. So after that, that means Olivia would give John 2 sweets again. So 6 minus 2 equals 4. 2 plus 2 equals 4, which means they both are equal. So as we see, they both are equal. So B is correct. So our answer for 24 is B.
Hello everyone, thank you for watching my video. Thank you. Please subscribe, like, share, and comment below. And if you like this video, please don't forget to smash that bell button and support for more videos. Thank you.